NASA releases a brutal report about Starliner's issues and blames management.
Disagreements over crew return options deteriorated into unprofessional conduct while the crew remained on orbit.
Meanwhile, the Artemis program continues testing before sending humans around the moon. The European Space Agency wants to blast space debris with lasers, and NASA's Perseverance rover gets a software update after 5 years on Mars. As always, we've got all that and more coming up this week in Spaceflight. The Starliner saga continues. This week, a lengthy report about the Starliner crew flight test was released, investigating what went wrong, but most importantly, how NASA management let it happen. It's not pretty, and NASA Administrator Jared Isaacman believes the agency's culture needs to change.
But the most troubling failure revealed by this investigation is not hardware. It's decision-making and leadership that if left unchecked, could create a culture incompatible with human spaceflight.
So let's quickly recap what happened. Starliner's CFT, or Crew Flight Test mission, launched on June 5, 2024, carrying 2 NASA astronauts, Butch Wilmore and Suni Williams, to the International Space Station. The first hours aboard Boeing's capsule were smooth sailing, but things went wrong as the capsule approached the ISS. The capsule's thrusters kept failing to an extent that Starliner temporarily lost 6 degrees of freedom control. So we had 2 astronauts on board a partially uncontrollable capsule approaching the ISS. Fortunately, ground teams managed to get the situation under control, and Butch and Suni safely arrived at their destination. Besides the failing thrusters, Starliner was also plagued by helium leaks, as 7 of the 8 helium manifolds on the spacecraft service module leaked during the missions. After all of that, NASA determined that Starliner wasn't safe for Butch and Suni to return in, and decided that the astronauts would come back home on SpaceX's Crew Dragon instead. Starliner returned home without its crew in September, 93 days into what should have been an 8 to 14-day mission. But on return, another issue popped up. A thruster on the capsule failed to fire on descent. According to the new report, this reduced the system to 0 fault tolerance. Yikes. But how did it get this far? After all, this wasn't the first failure in the Starliner program. Starliner's first uncrewed flight didn't make it to the ISS at all, and the capsule ended up in the wrong orbit due to software errors and 10 thrusters failing during the mission. As a result, NASA and Boeing decided to launch another uncrewed test, which also ran into issues on its first attempt. When it finally launched, it went fairly well, but not without 3 thruster failures. It seems there were plenty of opportunities to catch these issues, yet NASA still let its astronauts fly in an unsafe capsule. The agency wanted to find out how it let all that happen, so in February 2025, before Butch and Suni returned home on Crew 9, they launched an independent investigation to get to the bottom of it, and the results were made public this week. Now, exactly what caused all of the problems has yet to be identified, but it appears that Starliner has had design and engineering issues since the very beginning. Apparently, Boeing allowed components to operate outside of their certified limits. Also, Starliner's propulsion never had the 2 fault tolerance for deorbit burns that was required by NASA, but somehow this slipped through the cracks until after the original launch attempt of Butch and Suni's mission that scrubbed in May of 2024. But as Isaacman said, the most important conclusions from the report are not about the hardware, but rather the management issues that led to the current situation. Seemingly, management was too focused on the program's overall success and public perception, so much so that they signed off on issues prematurely and never got around to solving the root issues of the technical problems.
Programmatic advocacy exceeded reasonable bounds and placed the mission, the crew, and America's space program at risk in ways that were not fully understood at the time decisions were being contemplated. This created a culture of mistrust that can never happen again, and there will be leadership accountability.
The problems continued even after Starliner returned home following its crew flight test, as no mishap was declared despite all of the loss of control. Following the report's advice, NASA has now classified the 6 degrees of freedom control loss while approaching the ISS as a Type A mishap. Within the agency's mishap classification system, this is the most severe, corresponding to, quote, unexpected spacecraft departure from controlled flight, or over $2 million in damage as a result of the failure. Starliner's impact on space station operations well exceeded these costs.
Losing 6 DOF control is a huge deal. I actually want to give a lot of credit, and I mentioned it in my remarks earlier, to the flight controllers that made the decision to kind of challenge some of our flight rules and bring that crew to a safe haven, which is the International Space Station. Had that not taken place, had thrusters not been recovered, it could have very well been a different outcome. As I mentioned before, after we did undock Starliner and it autonomously re-entered, it came home zero fault tolerant for another. That was a CM thruster failure that we were not anticipating at the time. So the spaceship was not healthy.
So what's next? Well, NASA already decided that Starliner's next mission won't fly crew. It was supposed to fly in April, but it now seems likely that that flight will be pushed back even further. NASA and Boeing still don't understand what caused the technical problems, and Jared said in no uncertain terms that Starliner won't fly, crew or cargo, until those issues are resolved.
But we are not going to fly again, crew or uncrewed, until it's ready.
Jared clearly wants NASA to learn and improve from this whole ordeal, but that leaves us asking, where's Boeing? The company wasn't represented at the press conference, and Jared didn't elaborate why when asked about the lack of Boeing officials. Boeing released a statement afterwards. They're still working on solving the technical issues and claim to have made substantial progress. Meanwhile, they're trying to instigate cultural changes within the company, but all in all, they remain committed to the program. Now, we're hoping that NASA and Boeing use this opportunity to learn the right lessons. You really don't want to cut corners when it comes to human spaceflight. We've seen the disasters that can lead to. So, while we can't wait to see Starliner fly again, we hope it won't be until all of the problems are traced back to their root cause and solved. Spaceflight is amazing, but only if done safely. The European Space Agency is working on plans to remove space debris from low Earth orbit by blasting it with lasers. That's right, more space lasers. The agency plans to use a series of ground-based, high-power laser stations to gently nudge objects of space debris in low Earth orbit. Firing a precisely aimed laser beam, the system slightly decelerates the object through a tiny transfer of photon momentum. This should be enough to shift its trajectory and avoid a high-risk close approach with another satellite or piece of debris. The Omelette project, or Orbit Maintenance via Laser Momentum Transfer, was developed by a team of international partners led by the Institute of Technical Physics at the German Aerospace Center. There's a lot of complexity involved, which includes borrowing adaptive optics from the field of astronomy. These will overcome the atmospheric distortion, which would otherwise affect the laser beams. So how much power does it take to give space debris enough of a push? Well, early simulations predict around 50 kilowatts is needed, which is a significant amount of power to generate. The team at Trumpf Scientific Lasers in Germany plans to combine multiple units and merge their output into a single beam. The Omelette project is currently transitioning from a requirement definition stage to actual design and implementation. It all sounds like a very complex plan, so why are they doing all of this? Well, if you're wondering how big the challenge of space debris actually is, let's take a look at some numbers. There have been over 7,000 launches in the nearly 70 years since the space age began back in 1957. Those launches have placed over 25,000 satellites into Earth's orbit, of which roughly 67% are still in space, and just over half are still functioning, according to ESA. It's not just functioning and dead satellites up there, though. There's a lot of junk as well. To track and model the high volume of space debris around the Earth, the agency maintains a Meteoroid and Space Debris Terrestrial Environment Reference, or MASTER for short. This model estimates 54,000 objects in orbit greater than 10 centimeters in size, including active payloads. And there's a lot more debris that's much smaller than this, created by what we call fragmentation events. These can be caused by collisions, explosions, or other vehicle breakups, from equipment covers to paint flakes, or other degradation from aging spacecraft. These events have generated even more objects that are too small to be reliably tracked for avoidance, but they're large enough to damage satellites or spacecraft. Currently, ESA estimates that there are 1.2 million space debris objects between 1 and 10 centimeters in size, and 140 million that are smaller than 1 centimeter, all circling our planet at speeds of between 7 and 8 kilometers per second. ESA notes that, quote, even a 1 centimeter nut could slam into a valuable satellite with the force of a hand grenade. Now, you might be familiar with recent reports of damage to the Chinese Shenzhou 20 craft, which had to deorbit uncrewed after a micrometeoroid, or orbital debris, thought to be smaller than 1 millimeter, caused a crack through the outer layer of the spacecraft's viewport window. Another fragment caused a partial power loss in 2023 when it struck one of the Tiangong space station's solar arrays. Installing debris protection panels on the station has since become routine on spacewalks. Debris clouds from two major fragmentation events still dominate low Earth orbit. The Fengyun 1C anti-satellite test in 2007 caused the largest single breakup in history, increasing trackable objects by 25% at the time. 2 years later, the Iridium-33 satellite collided with the inactive Russian Cosmos 2251. This was the first known hypervelocity collision between two intact satellites and created thousands more trackable fragments and far more smaller ones. ESA's ambitious zero debris strategy, announced in 2022, is an initiative to make future space missions debris neutral by the end of the decade, and many launch providers already do everything that they can to mitigate orbital debris. Last year alone, SpaceX's Starlink satellites performed around 300,000 collision avoidance decisions, according to filings with the Federal Communications Commission. Last December, Starlink 6079 had a near miss when 9 satellites launched by a Chinese Kinetica 1 rocket passed within 200 meters of it. The company has recently announced Stargaze, a space situational awareness system which will use the star trackers aboard its Starlink satellites to generate around 30 million orbit observations each day. SpaceX is making this data freely available to all satellite operators to help avoid collisions and the risk of creating even more debris. Meanwhile, Omelette is just one of the several ESA initiatives to address space debris. Its forthcoming ClearSpace 1 debris removal mission still plans to capture the Probo 1 satellite and deorbit with it. Another European startup, Osmos X in France, also has a plan involving no contact, similar to Omelette but from space. The Albator project, announced last October, is also in early stage R&D. The concept would direct an ion or particle beam from one of its orbital transfer vehicles to nudge an object towards a controlled re-entry or away from an orbital region with high traffic. We'll keep an eye on all of these developing stories because sustainable spaceflight isn't optional anymore. And the future of space depends on how well we all clean up after ourselves. NASA continues progressing towards the first mission to launch humans on a moon-bound trajectory since the 1970s. We've followed the preparations for the Artemis II mission in previous episodes, but here's a quick recap just in case you missed it. The SLS rocket for Artemis II rolled out to the launch pad at the Kennedy Space Center's Launch Complex 39B in January. After hooking up all systems, NASA attempted its first wet dress rehearsal test on February 2nd, during which it loaded up the rocket with liquid oxygen and liquid hydrogen and worked through the countdown as it would on launch day, all without launching of course, as it was only meant to verify that everything was working correctly and to practice all procedures. But not everything went as planned, as hydrogen was leaking at higher rates than NASA allowed. The agency delayed the planned launch date to early March as a result, and allowed the 4 astronauts to come out of quarantine. NASA astronauts Reid Wiseman, Victor Glover, and Christina Cook, and Canadian Space Agency astronaut Jeremy Hansen have since continued training to prepare for their mission. Meanwhile, engineers tried to fix the hydrogen issue. They replaced seals in the leaking connections and did a partial fueling test on February 12th to verify the fix. That test ran into flow rate issues, and after replacing a filter in the ground support equipment, NASA decided to go ahead with this week's wet dress rehearsal. Now, these tests are no small ordeal, as they start over 49 hours before the simulated liftoff time. NASA had slightly altered the procedures, adding extra time to planned holds to deal with potential problems. Earlier, they had planned to forego practicing Orion closeout operations on this second wet dress rehearsal, but later added it back into the countdown. Then on Tuesday, the countdown clock started, counting down. Everything seemed to be progressing smoothly, although there was a small communications issue ahead of propellant loading on Thursday. That problem was quickly resolved, however, as the teams had prepared a backup plan, and from then on, everything went pretty much according to plan. Once the vehicle was loaded and the pad closeout teams had sealed up Orion, they even got to perform a couple of firsts for the Artemis program as a whole. Launch director Charlie Blackwell-Thompson explained.
We had a planned hold. We were going to demonstrate that 3-minute MPS hold constraint. We have never done that before. We did that yesterday, and we were successful in doing so. We held the clock at 1:30. For the 3 minutes, we actually went a little bit over the 3 minutes. We picked up and we counted down, and then we had a planned cutoff, and we went through our recycle with the flight hardware with a cryogenically fueled vehicle. Again, first time we've ever done that, validating our timelines. We expected it to take about an hour, a little over. We did it in 57 minutes. So very pleased with how that all went in retargeting a second T0. We picked up the count again at T-minus 10 minutes, and we counted down, and we had no holds, no planned holds, and nothing held us up in term count. And we went down and had a cutoff at 29 seconds, which concluded the terminal part of the count.
Late in terminal count, they did have to deal with one problem though. The booster's avionics had a small power issue, with systems reporting inconsistent measurements. They plan to look into this and make sure that it won't reoccur on flight day. Regardless, NASA is very happy with how the test went, and the hydrogen leaks seem to be fixed. That is, of course, insofar as hydrogen leaks can actually be fixed. That stuff is nearly impossible to contain, and on the Artemis I launch, they actually saw leak rates of 6%, but during the wet dress, it didn't get over 1.6%. So with that, NASA decided to proceed with launch preparations, targeting a launch on March 6th. As of Friday evening, the astronauts are also expected to go back into pre-launch quarantine at the Johnson Space Center in Houston. But that doesn't mean that NASA is all set for launch. They still have to complete the post-wet dress analysis, teams need to head back out to the pad to retest the flight termination system, and there's still a lengthy flight readiness review to come. Any of those could still delay the launch. Either way, we are getting really close now, and we might just see 4 astronauts head for the moon early next month. Let that sink in. Humans could fly around the moon in just a couple of weeks. Subscribe to follow along with all of the excitement. We will, of course, cover this mission live and have a bunch of really cool Artemis-related things in the pipeline. And if you enjoy our space news coverage, give us a like, and YouTube will know to send other space fans our way too. Now we'll take a look at some other stories across space, starting with NASA's Perseverance Mars rover, which has been roaming the red planet for 5 years. Now that's Earth years, of course, as it arrived on February 18th in 2021, and thanks to a new software update, it's now able to travel much greater distances without phoning home. One of the greatest factors limiting how much the rover can travel is its ability to know where it is. Without GPS like we have on Earth, that's actually been quite challenging. And after a long drive, Percy could get its location wrong by as much as 35 meters. So, after each drive, it takes a 360-degree panorama image and it sends that back to Earth. Ground teams then compare the surface features with satellite imagery to determine Percy's exact position. Now, of course, it'd be much more efficient if the rover could just do that all by itself, but its 2 main computers aren't exactly powerful. The computers are radiation hardened to survive the Martian environment, and they're based on technology from 1997. But the rover happens to carry another computer that's over 100 times faster. Percy needed a system to communicate with its robotic partner, the small helicopter Ingenuity, and the helicopter base station, which filled that role, uses a commercial smartphone processor from the mid-2010s, which is much more powerful than Percy's main computers. Now, as we all know, Ingenuity took its last flight in 2024, and Percy has since lost sight of the helicopter, so the system was just sitting idle. Now, NASA engineers have repurposed the computer for navigation, and it's now able to run the Mars Global Localization System. It essentially does the same thing that ground teams used to do: compare images from the rover's navigation cameras with onboard terrain maps. Percy used this system in regular operations for the first time on February 2nd and again on the 16th, and it works really well. In just 2 minutes, Percy can pinpoint its location to within 25 centimeters. Combine that with recently tested AI-assisted route planning, and NASA suddenly has a much more capable robotic explorer in its arsenal, even though it's already been driving around the red planet for 5 years. Blue Origin has rolled its Mark 1 lunar lander, Endurance, into the Thermal Vacuum Chamber A for approximately 11 days of testing. Endurance recently left Florida in late January and arrived at NASA's Johnson Space Center in Houston, Texas, where it's begun testing at the same facility as the Apollo spacecraft and, more recently, the James Webb Space Telescope. Chamber A is one of the largest vacuum chambers in the country, standing roughly 27 meters tall and 17 meters in diameter. Virtually all of the air is removed to create a near-perfect vacuum environment that replicates what the lander will experience in space. Endurance will be exposed to temperature extremes ranging from -50 to positive 30 degrees Celsius to ensure that it can perform its mission and maintain thermal equilibrium. While the lunar surface can swing far beyond those extremes, these tests will validate the lander's designed operating range and thermal control systems. The chamber enables teams to check that a wide range of systems operate correctly in a vacuum and under thermal stress, from the avionics and batteries to propulsion components, deployment systems, thermal coatings, and seals. This is a critical step on the lander's path to the moon. Endurance is slated to carry 2 NASA science and technology payloads to the lunar surface as part of the agency's Commercial Lunar Payload Services Initiative and the Artemis campaign. The Blue Moon Pathfinder mission is one of 2 test missions which will prove out critical systems such as the BE-7 engine, avionics, communications, and of course, a precision landing. We look forward to Endurance living up to its name and passing these latest tests with flying colors as it moves one step closer to flight. Stoke Space has completed work on its launch pad at historic Space Launch Complex 14 within the Cape Canaveral Space Force Station in Florida. The launch complex now includes commodity farms for oxygen, propellant, and water, and a new purpose-built horizontal integration facility. This is where stages and payloads will be assembled and integrated before being rolled out to the pad for vertical launch preparations. Work began in late October 2024, following a roughly 2-year environmental review process. The pad was originally built in the late 1950s and supported Atlas family launches, including 4 Project Mercury missions. It's been almost 60 years since the pad's last launch in 1966, launching an Agena target vehicle for the Gemini 12 docking test, which wrapped up the Gemini program. Stoke also announced an extension last week to its Series D financing round, adding a further $350 million to the $510 million already raised last October. Total funds raised now stand at $1.3 billion. The additional capital will allow the company to accelerate its product roadmap and expand the production capacity for its fully reusable Nova launch vehicle. Continuing the theme of upcoming rockets, Rocket Lab has been testing the interstage for its reusable Neutron vehicle at the company's Space Structures Complex in Middle River, Maryland. The interstage must withstand not only the stresses of ascent, but also re-entry as it returns to land. Unlike traditional expendable rockets, Neutron's interstage remains attached to both the first stage and the vehicle's integrated Hungry Hippo payload fairing, returning to Earth as a single structure for a vertical landing. The qualification campaign will see the interstage undergo a series of static load tests, simulating flight conditions by applying up to 1,000 tons of force. This will replicate the aerodynamic and structural loads experienced on the way to orbit and during recovery. Neutron will launch from the recently completed Launch Complex 3 at the Mid-Atlantic Regional Spaceport on Wallops Island, Virginia. This week, Rocket Lab hosted the U.S. Space Force's National Security Space Launch Team at the site as the company works towards certifying Neutron for future national security missions. Rocket Lab was selected last year to compete in the NSSL Phase 3 Lane 1 program, positioning Neutron alongside established heavy lift providers for Department of Defense launches once it meets certification milestones. Stoke Space was also selected. Using the strategy that made Electron one of the world's most frequently launched rockets, Rocket Lab is now laying the groundwork to scale Neutron production and launch cadence from day one. Dedicated facilities in Maryland and Virginia now underpin every element of Neutron's journey from factory floor to the launch pad. From Rocket Lab, we move to Astrolab. 1 year after announcing the Flip rover's ride to the moon aboard Astrobotic's Griffin 1 lander, Astrolab is making progress towards the planned summer launch on Falcon Heavy. FLIP, or the Flex Lunar Innovation Platform, to give its full name, is a technology demonstrator designed to land near the lunar South Pole. The lunar rover will replace NASA's canceled Viper rover aboard Griffin 1, and this week the team completed its first payload mechanical integration. This is a key milestone in Astrolab's effort to bring advanced computing to the moon through a partnership with Hewlett-Packard Enterprise. The collaboration will focus on deploying HPE's spaceborne computer technology to the lunar surface inside Astrolab's lunar vehicles, a rugged AI-capable edge computing platform previously proven aboard the International Space Station. Deploying space-grade computing directly on the moon reduces reliance on slower Earth-to-moon communications and enables real-time local data processing. If successful, the mission won't just demonstrate mobility, it'll mark a first step toward laying the groundwork for a computing infrastructure that'll eventually support a sustained lunar presence. Scottish rocket company Orbex has officially closed up shop, but in the last few days before going belly up, the company shared some images of the hardware that it had produced. So let's take a look. Throughout its decade of operations, the company had been working on its rocket called Prime, a 19 meters tall propane-fueled smallsat launcher. Over the years, the company had conducted many successful tests with its 3D printed engine, and we even got to see a prototype of the rocket a few years ago as Orbex showed it off with lots of smoke and fancy lighting. Now that rocket was mostly for show, and certainly wasn't ready to fly yet. Since then, we've heard so little from Orbex that some of us questioned whether they even had any actual flight hardware at all, and strangely, they waited until the very last minute to show what they were working on. The photos released this week show fairings, an integrated second stage, and first stage tanks ready to be assembled into a functional rocket, which they had planned to launch this year. Orbex also released a photo of a fully assembled payload and avionics module, which was ready for testing ahead of that first flight. But that flight never came. So what's next? Well, as we reported last week, another Scottish rocket company, Skyrora, showed interest in taking over some of Orbex's assets, including its spaceport. Meanwhile, Orbex has donated some rocket models and engine parts to several museums across the United Kingdom. Now, for all of the engineers and team members who put their heart and soul into Prime, we feel you. We hope that all of the hard work that you put into it will eventually feed into some future launch vehicle that will make it into space. This is your weekly space traffic report provided by NextSpaceflight. It was a quiet week with only SpaceX launching rockets. The company launched 3 Starlink missions, 1 from California and 2 from Florida. The last one lifted off from Florida during the Artemis II wet dress rehearsal that we discussed earlier, and the landing on this flight was kind of special, as booster B-1077 touched down on drone ship Just Read the Instructions, which was stationed in the Bahamas. SpaceX tested this trajectory last year, but this week's mission was the first to fly that way operationally. Next week, we'll have 5 more Starlink missions, 2 from California's Vandenberg Space Force Base and 3 from Florida. Rocket Lab is set to launch its mission named That's Not a Knife no earlier than February 24th. For this mission, Electron will lift off from Launch Complex 2 in Virginia, launching in its hypersonic haste configuration. The flight will carry a scramjet-powered aircraft for Australian company Hypersonics. Japan's Space One is also getting ready to launch the 3rd flight of its Kairos rocket next week. The mission is set to lift off no earlier than the 25th from Space One's own spaceport Key. The first 2 flights didn't get past separation of the rocket's solid first stage, so hopefully this next one will see more success and deliver the 4 payloads into their intended orbit. Later in the week, Firefly is planning the return to flight of its Alpha rocket. The previous flight in April of last year didn't get to orbit as the result of an issue at stage separation. The upcoming mission, called Stairway to 7, in reference to it being Alpha's 7th flight, will test technology for Alpha's upcoming Block 2 version. The flight was originally supposed to launch last week, but Firefly decided to delay it because of weather. The launch window is now set to open early February 28th UTC, which is still February 27th local time. So that's everything on the schedule at the time of recording, but more launches could always pop up, especially as China is getting back from its break for Chinese New Year. So keep an eye on nextspaceflight.com or download the app on your phone for the latest updates. And that's your weekly update of spaceflight news. I'm Elysia Segal for NSF, and we'll see you all again next week to recap this week in spaceflight.